Day 42 of 100 Days of Code as I'm learning the Python programming language. This video is to track my progress and to hold myself accountable in my learning. For day 41, I actually used the copy library and went over how to do some copying of day 42. I'm focusing on shallow copies of lists as well as deep copies. We're going to pretty much just focus on simple lists, as there are other complex lists that you can work with to perform shallow and deep copies. I'll start by creating a new list. So this one we'll just call threats, and I'll assign this list a few threat elements. So we'll say C2, beacon, spyware, and brute force. If I print out this list, you can see that my list is here. I'm actually going to, and this will just be the shallow list. So shallow copy on list. And I'll start by creating a new threat list. We'll just call it new threats. And I'm actually going to use the assignment operator to assign it to our first list. So this creates a copy of it. And then if I print those two lists out, we'll say original list is threats. And then we'll say new. So when I execute this, you can see that our original list and our new list are both here, and they're actually identical. This is what it means to make a shallow copy of a list. So in memory, the two lists are essentially the same. Now let's go ahead and pull out an element from our list. And I'll do new threads. Using our brackets, we'll specify the index position. And this, remember, we're working with binary, so the 0 actually is the index position for the first element, which is C2. And I'm going to reassign this, and I'll just reassign it insider threat. Now, if I reprint these lists, and I'm just going to basically grab this, paste it here. This is going to reprint our list. And you can see that it changed both our threats list as well as our copy, our shallow copy, which is titled the new underscore threats list. So again, this assignment operator here assigns the new threats variable to our original threats list. And in memory, again, this is the same list. So if you make changes to one list, as we did here, it's actually going to change the original. So this is working with shallow copies on list. We're going to get rid of this, and I'll show you how to do a deep copy on a simple list. We'll use our original threat list, and you're actually going to need to import in the copy library. This will allow us to use the copy module as well as the functions and classes that are within it. I'm going to assign the same threats list with the same elements. And then if we go about printing this out, you can see that we have our list here. Now to actually do our deep copy, we're going to make use of the copy module. So we'll say new threads, copy, and this will use the copy function of our copy module. And we're copying the threats list. So if I print these two lists, and you can see our lists are identical. Now we're going to actually change one of the elements as we did with the shallow copy, and we'll update the element to be insider thread. So we'll just say new threads. We're going to update the index position 0, which is still going to be C2, and assign it insider threads. And then now if we print both of these again, so just for clarity's sake, I'll get rid of this one. But you can see here that they're the same here, but they change here. So I'm just going to get rid of this one just for clarity's sake. So here's our original list. And you can see here when we made this update of index position 1, that the new list made the update, but the original list did not update. This is because essentially an entirely new list is created, which is independent of the other. Changes that you make on the new copy will not affect the original copy because this is a deep copy. And in memory, the deep copy actually differentiates the two lists and it uses the copy function in the copy module to do so. And so that's why you see for this update, the new list has changed, but the original is not. So that is the difference between the shallow versus the deep copy on simple list.